Alright guys, today we're going to be looking at how to solve logarithmic equations. So we've already looked at solving exponential equations. We're going to do the opposite and solve logarithmic equations. So let's go back and review again. Remember that the inverse of x equals 2 to the y is, or y equals 2 to the x is x equals 2 to the y. So we switch x's and y's. And we also learned that we can rewrite that in logarithmic form as y equals log base 2 of x. Remember we go 2 to the y equals x. Also, remember we talked about yesterday, or in the previous video, and when we were talking about inverses, that if you have two functions, f of x and g of x, and they're inverses, that when you do f of g of x and g of f of x, they'll always give you the same thing, and they'll always simplify to x. So using that idea, let's say that f of x is a to the x, and g of x is log base a of x. Those are our inverses. 2 to the x, log base 2 of x, a to the x, log base a of x are inverses. Then if I do f of g of x, remember that's put g into f. So g into f will give me a to the log base a of x. That simplifies to x. So another way to think about that is like what we talked about with solving exponential equations. A to the and log base a cancel each other out, and you're left with just the x. So now we're going to actually solve some problems involving those. You may want a calculator, so if you don't have one handy, you might want to pause the video and get one. So say we've got log base 3 of x equals 4, and my x is inside of the log base 3. Well, to get rid of log base 3, the inverse of a log is an exponential. So the opposite of, or inverse of log base 3 is 3 to the. So what I'm going to do is I'm going to exponentiate both sides of this and just make both of these 3 to the log base 3 of x and 3 to the 4th. So 3 to the log base 3 will cancel and give me x equals, and then 3 to the 4th, I can get my calculator out, and that's going to be 81. So x has to be 81. If we look at the next one, we have log of 2x plus 1 equals 2. I want to get rid of the log because my exponent's in the parentheses. Well, remember that when the base is missing on a log, it's understood to be base 10. So to get rid of log, I would go 10 to the, you might want to think of it as 10 to the log base 10, cancel. And that's just going to give me 2x plus 1. And then 10 to the second would be 100. And then now it's a linear equation, and I can solve that by subtracting 1. 2x would be 99, divided by 2. And I'm fine with you just leaving it as 99 halves. Now remember, you will have some of these that you cannot use a calculator for. So let's look at the next one here. We have 3 log base 2 of 4x minus 1. So the first thing I want to do is get rid of this 3. I can't start by going 2 to the. And let's look at that real quick since this is log base 2, because the 3 is in the way, and you have to have 2 to the log base 2. So the easiest way to do this then is to start by dividing by 3. And that's going to give me log base 2 of 4x minus 1 equals 4. Now I can get rid of the log base 2 by doing 2 to the. So 2 to the log base 2 cancels. 4x minus 1 equals 2 to the 4th. Well, 2 to the 4th is 16. And again, we're down to a linear problem, so we'd add 1. 4x would equal 17, and divide by 4. And again, just leave your answer as 17/4. So x is 17/4. Let's look at just a couple more, and then we'll do a word problem. We have the natural log of 5x equals 4. Now remember that the opposite or inverse of a natural log is e. So to get rid of a natural log, we want to do e to the. Well, e to the natural log cancels, and you get 5x equals, and we'll just leave that at e to the 4th right now. And then to solve for x, I would divide by 5. So if we're on the no calculator part of the test, you'd leave your answer as e to the 4th over 5. Now let's go ahead and get an answer for that. So I can use my calculator, find e to the 4th and then divide that by 5, and I get 10.919, or since there's a 6 after that, it could be 10.920. All right, now let's look at the next one. We have 5 natural log of 2x plus 3 minus 1 equals 24. So I want to solve this kind of like I would a linear equation. Let's imagine that that's all what I want to get by itself. That's kind of like my x. So the first thing I would do would be add 1. That's going to give me 5 natural log 2x plus 3 equals 25. Then I'm going to divide both sides by 5. I get the natural log of 2x plus 3 equals 5. Then I need to get rid of the natural log, so I'm going to do e to the on both sides. Those are going to cancel. 2x plus 3 would equal e to the 5th. Again, we're trying to get x by itself, so we would subtract 3. And that's going to give me that 2x equals e to the 5th minus 3, and then divide by 2. So if you're not allowed to have your calculator, you would leave your answer as e to the 5th minus 3 over 2. Or we can get our calculator and do e to the 5th, you might want to push enter there, minus 3, push enter, and then divided by 2. And I'm getting the x is 72.707 if I round to 3 decimal places. Now, one last thing we're going to do with this is kind of look at this in terms of some word problems that we've done previously where we did them graphically. So here's our problem. We have that biologists use the model n equals k times log of a. If we are estimating the number of species n in an area A, k is always going to be some constant, which at this point I don't know. And notice what it tells me. There are 200 species, so that's going to be some n, in a rainforest of 500 square feet, or kilometers, so that's A. Then how many species will be left when half of the rainforest is destroyed by logging? So that, again, is another A. Well, if I look at this original information, if I knew n and I knew A, that would allow me to find k. So that's the first thing I want to do. So let's put in that. So 2,800 equals k times the log of a, which is 500. So I could actually solve for k here. This is a little easier than what we were just doing because our variable is not with our logarithm or as part of the logarithm. So really all I need to do here is just divide by the log of 500. So if I do that, so if I take 2,800 and divide by the log of 500, I get that my k is 1,037.43. We'll go ahead and round that to 3. So now I actually know I could put that in for k, and my equation would be 1,037.433 log of a. And then the last question is, how many species are left? So I want to know n. Species is n. So what's n when there's half of the rainforest that's been destroyed or half of it still left? Well, remember, we started with 500 square kilometers. So I want to know what happens now that there's 250. And now, oh, I put the 250 in the wrong place. I just grabbed my calculator and put that in, so 1,037.433 times the log of 250. And I get that there is 2,487, if I round down, because we're talking about species. So there's less than 2,500 species left out of the 2,800. So you've got 2,487 species left. These are the kinds of word problems that you're actually going to see when we start reviewing for the test. Because again, about half of your test over this chapter will be solving word problems.